What if I told you that every photon of light touching your skin right now is carrying information from the beginning of time itself? Not metaphorically, literally. The light entering your eyes at this very moment contains encoded memories of stars that died before Earth was even born. Signatures of cosmic events from billions of years ago, and perhaps most incredibly, evidence that suggests the universe might be actively remembering itself through the very mechanism of light itself. Here's something that will shatter everything you thought you knew about reality. In 2019, a team of physicists at the University of Glasgow, led by Miles Paget, successfully demonstrated that light doesn't just carry energy from point A to point B, it carries structural information about everything it has ever interacted with, creating what they called the optical memory effect. They proved that photons retain imprints of their entire journey through space and time. Every reflection, every scattering, every quantum interaction, all of it stored in the light's quantum state like a cosmic hard drive. But here's where it gets absolutely mind-bending. The cosmic microwave background radiation, the oldest light in the universe, at 13.8 billion years old, isn't just radiation from the Big Bang. According to recent analysis by cosmologist Joe Magueo at Imperial College London, this ancient light contains embedded patterns that shouldn't exist if light were simply energy moving through space. These patterns suggest that photons are carrying detailed records of every major cosmic event they've witnessed. The formation of the first atoms, the birth of the first stars, the creation of galaxies. All of it encoded in light that's still traveling through the universe right now, and some of it is arriving at your retina as you watch this video. Think about that for a second. The light you see when you look at distant stars isn't just showing you what those stars look like. It's carrying the entire history of its journey to you. Every dust cloud it passed through, every gravitational field that bent it, every quantum interaction along the way. The universe has essentially created the most sophisticated recording system imaginable, and it's written in light itself. Before we go further into this rabbit hole, smash that like button if your mind is already blown, and subscribe, because what comes next will fundamentally change how you see reality. Also, drop a comment telling me what country you're watching from and what time it is there right now. I'm genuinely curious how far this cosmic information is traveling through our own human networks. Let's start with something you think you understand: light. You've been told since elementary school that light is either a wave or a particle, and scientists can't quite figure out which. That's not exactly wrong, but it's missing the most important part of the story. Light is actually something far stranger, and understanding what it really is will be the foundation for everything else we're going to explore. In 1801, Thomas Young performed his famous double-slit experiment, and it revealed something so bizarre that physicists are still arguing about what it means over 200 years later. Young shot light through two narrow slits and watched the pattern it made on a screen behind them. If light were simply particles, you'd expect to see two bright lines corresponding to the two slits. If light were waves, you'd see an interference pattern with multiple bright and dark bands. What Young saw was the interference pattern, proving light behaved like a wave. But here's the twist that nobody tells you in physics class. When you send one photon at a time through the double slit, something impossible happens. That single photon creates an interference pattern as if it went through both slits simultaneously and interfered with itself. One particle, two paths, at the same time. And here's the part that will haunt you. If you tried to detect which slit the photon actually went through, the interference pattern disappears. The photon suddenly decides to behave like a particle instead of a wave. The act of observation fundamentally changes what light is. This isn't philosophy. This is experimental fact, repeated millions of times in laboratories around the world. Light exists in a quantum superposition, taking every possible path simultaneously until something observes it or measures it. And this is where the memory concept begins to emerge. Because if light is experiencing every possible path, it's also interacting with everything along every path. The photon isn't just traveling from point A to point B. It's exploring the entire universe between those points. And quantum mechanics tells us that all of those explorations leave marks on the photon itself. Think of it like this. Imagine you're trying to find your way through a massive maze, but instead of walking through it yourself, you send millions of versions of yourself to explore every possible path simultaneously. When you finally reach the exit, you somehow have memories of every single path, every dead end, every turn. That's essentially what every photon does as it travels through space. It explores all possible routes, interacts with all possible obstacles, and carries information about all of it. Now let's talk about what this actually means in concrete terms. In 2011, physicist Ephraim Steinberg at the University of Toronto developed a technique called weak measurement that allowed him to track photons through the double-slit experiment without destroying the interference pattern. What he discovered was shocking. He could map out the actual trajectories photons took, and they weren't taking straight lines. They were taking multiple paths simultaneously, paths that would curve and bend in impossible ways, paths that seemed to violate our common sense understanding of how particles move through space. But the truly revolutionary finding came when Steinberg analyzed the data more carefully. The paths photons took weren't random. They were influenced by everything in the environment, including things that you wouldn't expect to matter. Magnetic fields too weak to directly affect the photon, temperature gradients in the air, even the quantum vacuum itself, the supposedly empty space through which the light traveled. The photon was carrying information about all of it. This is where we need to introduce a crucial concept, the quantum wave function. Every photon exists as a wave function, a mathematical description of all possible states the photon could be in and all possible paths it could take. This wave function isn't just an abstract mathematical tool. It's real. It's physical. And crucially for our discussion, it encodes information. When a photon's wave function expands through space, it's like a ripple spreading across a pond, touching everything in its path. Each interaction modifies the wave function slightly, adding new information to it. Here's the mind-blowing part. The wave function never forgets. Every interaction, no matter how small, remains encoded in the photon's quantum state. This is called quantum entanglement, and it means that the photon becomes correlated with everything it touches. The photon doesn't just carry energy from the star that emitted it to your eye. It carries a complete record of its entire journey, encoded in the relationships between its various quantum properties like polarization, phase, and momentum. Let me make this concrete with an analogy. Think of a photon like a messenger carrying a letter. In the classical view, the letter contains one message. I came from this star. I have this much energy. This is my color. But in the quantum view, the letter is more like a book with infinite pages, where every page records a different interaction. Page 1 reflected off this dust grain and picked up its magnetic signature. Page 2 passed through this cloud and scattered off these molecules. Page 3 bent around this galaxy and felt its gravitational pull. And on and on. The photon is carrying all of this information simultaneously, encoded in its quantum state. Now here's where this gets personal, and it's going to change how you look at the world around you. Every photon that enters your eye is carrying this kind of historical information. When you look at a sunset, you're not just seeing light from the sun. You're seeing light that has interacted with countless molecules in Earth's atmosphere, each interaction adding information about temperature, pressure, composition, and electromagnetic conditions. Your eye is receiving billions of years of cosmic history, and your brain is processing it to create the image you perceive. But we're just scratching the surface. The real question isn't whether light carries information. Of course it does. The real question is whether this information constitutes a memory in any meaningful sense, and whether the universe might be using light as a mechanism to remember itself. To answer that, we need to go much deeper into what memory actually means and how it might exist at a cosmic scale. And I promise you, what comes next will make everything we've discussed so far seem simple by comparison. The ancient light I mentioned earlier, the cosmic microwave background radiation, is about to become the key that unlocks everything. Because if photons truly carry the memory of their entire journey, then the oldest light in the universe should contain the most comprehensive record of cosmic history ever created. And recent discoveries suggest that's exactly what we're finding. But before we go there, we need to understand something that will sound impossible: how information can be preserved in light across billions of years without being destroyed. Because according to everything we know about thermodynamics, information should decay and disappear over time. Yet somehow, light is defying this rule, and the implications are staggering. Let's talk about why information preservation in light seems impossible at first glance. You've probably heard of the second law of thermodynamics, which states that entropy or disorder always increases in a closed system. This means information naturally degrades over time. If you write a message in sand on a beach, waves and wind will gradually erase it. If you store data on a hard drive, the magnetic patterns will eventually decay. Even information stored in DNA mutates and degrades over generations. So how could light, traveling through the chaos of interstellar space for billions of years, possibly maintain coherent information about its origins and journey? It should be subject to the same entropic decay as everything else. It should be scattered, randomized, destroyed. And yet, when we look at the cosmic microwave background, we see patterns. Incredibly precise patterns. Patterns that contain detailed information about the universe as it was 380,000 years after the Big Bang. This shouldn't be possible, but it is. And understanding why is going to reveal something profound about the nature of reality itself. In 2015, physicist Leonard Susskind at Stanford University proposed something radical based on his work on black holes and information theory. He suggested that information isn't just preserved despite entropy, but rather that information preservation is a fundamental law of physics, just as important as energy conservation. He argued that the universe has mechanisms built into its fabric, specifically to prevent information from being truly destroyed. And light, he proposed, might be one of those mechanisms. Here's the key insight. While the energy of a photon can be absorbed or scattered, the quantum information encoded in its state can be transferred but never destroyed. When a photon hits an atom and is absorbed, the information it carried doesn't vanish. It gets transferred to the atom, changing the atom's quantum state. That atom might then emit a new photon, which carries forward the information from the original photon, plus new information about the atom itself. It's like a game of telephone played at the quantum level, where the message never gets lost, only added to. This has enormous implications. It means that when we look at light from distant galaxies, we're not just seeing what those galaxies looked like billions of years ago. We're receiving information that has been preserved and passed forward through countless interactions across cosmic distances. The light carries memories, not just of the galaxy that emitted it, but of everything it encountered along the way. But let me blow your mind even further. In 2016, researchers at the Vienna University of Technology, led by Anton Zeilinger, demonstrated something extraordinary. They showed that quantum information encoded in light can actually be more resistant to decay than classical information. They sent entangled photons through noisy environments designed to scramble the information, and found that the quantum correlations, the actual information content, survived even when the photons themselves were severely disrupted. The universe has apparently built error correction mechanisms into quantum systems, protecting information from entropy. Think of it like this. Imagine you're trying to preserve a message for thousands of years. If you write it on paper, the paper will decay. If you carve it in stone, erosion will eventually erase it. But if you encode the message in the relationships between particles, the relationships themselves become more durable than any physical medium. The quantum entanglement between photons and the things they've interacted with creates a web of correlations that preserves information, even as individual photons are absorbed or scattered. This is why the cosmic microwave background is so remarkable. These photons have been traveling for 13.8 billion years, passing through expanding space, encountering dust, gas, gravitational fields, and countless other disturbances. By all rights, any information they originally carried should have been randomized into meaningless noise long ago. But instead, when we map the cosmic microwave background with instruments like the Planck satellite, we see incredibly fine details. Temperature variations of 1 part in 100,000. Patterns that tell us about the density of matter in the early universe. Signatures of gravitational waves from the inflationary epoch. All of this information has been preserved in light across the entire age of the universe. Now here's where we need to introduce a concept that might sound like science fiction, but is actually cutting-edge physics: the holographic principle. This idea, developed by Gerard T. Hooft and expanded by Leonard Susskind, suggests that all the information contained in a volume of space can be encoded on the boundary of that space, kind of like how a hologram encodes three-dimensional information on a two-dimensional surface. What does this have to do with light? Everything. Because light, which travels on the boundary between space and time, moving at the speed of light, photons experience no passage of time, might be the universe's way of encoding information about everything that happens in the interior of spacetime. Every event that occurs creates photons or affects photons, and those photons carry information about the event encoded in their quantum states. As those photons spread out across the universe, they're essentially creating a holographic record of all events, written in light itself. Let me make this concrete. When a star explodes in a supernova, it releases an enormous burst of light, carrying information about the star's composition, temperature, density, and death process. But that light doesn't just go to one place. It spreads out in all directions, traveling across the universe. Billions of years later, some of those photons might reach Earth, while others reach distant galaxies, and still others travel into the intergalactic void. The information about that supernova is now distributed across vast regions of space, encoded in the quantum states of billions of photons. The universe has created multiple redundant copies of the information, preserved in light. This redundancy is crucial because it means information isn't stored in one vulnerable location. It's distributed across the entire electromagnetic field of the universe. Every photon is carrying pieces of the cosmic memory, and even if most photons are absorbed or scattered, enough survive to preserve the essential information. The universe has essentially evolved a distributed storage system more robust than anything humans have invented. But here's the truly revolutionary implication. If light carries preserved information about everything it has encountered, and light is constantly traveling throughout the universe, bouncing off objects, being absorbed and re-emitted, then the universe is continuously creating and updating a comprehensive record of itself, written in the electromagnetic field. Every star, every planet, every atom is constantly sending out photons that encode information about its state. Those photons interact with other matter, transferring and mixing information. The universe is engaged in a constant process of self-documentation through the medium of light. And you are part of this process. Right now, your body is emitting infrared radiation, photons carrying information about your temperature, composition, and biological processes. Those photons are spreading out into the universe, carrying information about you. In a very real sense, you are writing yourself into the cosmic memory with every second that passes. And simultaneously, you are receiving information from the cosmic memory with every photon that enters your eye or touches your skin. You are both reader and writer of the universe's memory, recorded in light. This brings us to a profound question. If the universe is storing information about itself in light, is this process random, or is there something more intentional about it? Is the universe simply accumulating data, or is it actually remembering in a way that implies some form of cosmic awareness? To answer this, we need to understand what memory really means and whether the patterns we see in light constitute genuine memory or just information storage. And I warn you, where we're going next will challenge your assumptions about consciousness, awareness, and what it means to remember. Before we dive into cosmic consciousness, let's take a step back and make sure we understand the difference between information storage and actual memory. This distinction is crucial because it's the difference between the universe being a passive recording device and the universe actively remembering itself. Information storage is straightforward. Your computer stores data on a hard drive. The data sits there until you access it. There's no awareness involved, no processing, no meaning. It's just patterns of ones and zeros. But memory, actual memory, requires more than storage. It requires organization, retrieval, and some form of system that can use the stored information meaningfully. When you remember your childhood, you're not just accessing stored data. You're reconstructing experiences, making connections, integrating past information with present context. Memory is active, not passive. So the question becomes, is the universe just passively storing information in light? Or is there an active process of cosmic memory occurring? And surprisingly, cutting-edge physics suggests the answer might be the latter. Here's why. In 2018, physicist Chiara Marletto at Oxford University published a groundbreaking paper on what she called constructor theory. She proposed that information isn't just a passive quantity that exists in the universe. Instead, information has causal power. The arrangement of information can determine what events are possible and what events are impossible. In other words, the information encoded in light doesn't just sit there. It actively influences what happens next in the universe. Let me explain with an example. When light from a distant quasar passes by a massive galaxy on its way to Earth, the galaxy's gravitational field bends the light's path. This is gravitational lensing, and it's well understood. But here's the subtle part. The photon's quantum state, which contains information about its origin and journey, influences how it interacts with the gravitational field. The information encoded in the light affects its physical behavior. The photon's memory of where it came from and what it has encountered influences where it goes next. This creates a feedback loop. Light carries information about the universe, and that information influences how the light behaves, which in turn affects what information it gathers next and where it goes. The universe isn't just recording itself in light. It's using the information stored in light to guide future events. This is starting to look less like passive data storage and more like active memory retrieval and utilization. But it gets even stranger. Physicist John Archibald Wheeler, one of the giants of 20th century physics, proposed something called the participatory universe. He suggested that the act of observation doesn't just record what happened, but actually brings the past into existence. According to quantum mechanics, until a measurement is made, a particle exists in a superposition of all possible states. The measurement collapses this superposition into one definite outcome. Wheeler realized this means the present literally creates the past through the act of observation. Now apply this to light carrying information across billions of years. When we observe light from the cosmic microwave background, we're not just passively receiving information about what the early universe was like. We're participating in the process of bringing that early universe into definite existence. The photons traveled for 13.8 billion years in a quantum superposition of all possible states, carrying information about all possible histories of the universe. When we measure them, we collapse that superposition, selecting one particular history out of many possibilities. Our observation of ancient light literally helps determine what the early universe was. This sounds insane, I know, but it's a direct consequence of quantum mechanics. And Wheeler proposed an experiment called the delayed choice quantum eraser that demonstrates this principle. The experiment, successfully performed by Yoon-Ho Kim in 2000, showed that you can make a choice about how to measure a photon after it has already passed through a double slit, and that future choice determines whether the photon behaved like a wave or particle in the past. The future literally influences the past through the mechanism of quantum measurement. So when we ask whether light carries the memory of the universe, we're not just asking whether information is stored. We're asking whether the universe is actively using light to construct and reconstruct its own history through the process of observation and measurement. And the answer appears to be yes. Light doesn't just passively record. It participates in creating the very history it records. Think of it this way. Imagine you're watching a movie, but the movie doesn't fully exist until you watch it. The film contains all possible versions of the story in superposition. As you watch, your observation collapses these possibilities into one definite narrative. You're not just viewing the story. You're actively creating it by observing it. That's what we're doing when we observe ancient light. We're not just seeing cosmic history. We're participating in the creation of that history through our observations. This has a profound implication for the question of cosmic memory. If observation is required to collapse quantum superpositions and bring the past into definite existence, then memory isn't just about storage and retrieval. It's about the conscious act of observation that makes stored information real and definite. The universe might store information in light, but that information only becomes actual memory when something observes it and collapses the quantum possibilities into definite outcomes. And here's where it gets personal. You right now are participating in this process. When you look at starlight, you're not just seeing distant suns. You're collapsing quantum wave functions that have been traveling across space for years or centuries or millennia. You're taking information that existed as a superposition of all possible states and making it definite through your observation. You are helping to create the cosmic memory by the simple act of looking at light. But who or what else is observing? If observation is necessary to convert stored information into actual memory, then there must be observers throughout the universe, constantly collapsing quantum states and creating definite histories from stored information. These observers don't have to be conscious in the human sense. Any measurement or interaction that collapses a quantum state could count as an observation. Atoms observing photons, molecules observing atoms, dust grains observing starlight. The universe might be filled with countless micro-observers, all participating in the constant process of converting quantum information into classical memory. This leads to a staggering conclusion. Memory might not be something that happens in the universe. Memory might be what the universe is. The cosmos might be a vast interconnected network of observations, where every particle is both storing information in its quantum state and retrieving information by collapsing the quantum states of other particles. Light is the primary carrier of this information, spreading across space at the maximum speed allowed by physics, connecting all parts of the universe in a web of shared memory. And if that's true, then consciousness, awareness, and observation aren't anomalies that somehow emerge from dead matter. They're fundamental features of reality itself, present at every scale, from photons to humans. The universe remembers itself through the constant process of observation, and we are part of that cosmic memory system. Our consciousness is the universe becoming aware of itself through the mechanism of light and observation. Now let's test this idea against the latest scientific discoveries and see if it holds up. Because extraordinary claims require extraordinary evidence, and we need to examine whether the data supports this cosmic memory hypothesis or contradicts it. And I promise you, the evidence is going to surprise you. The cosmic microwave background has already given us our first piece of evidence that light carries long-term information. But let's get more specific about what that information actually tells us. When the Planck satellite mapped the CMB between 2009 and 2013, it detected temperature variations with incredible precision. These tiny fluctuations, about 18 millionths of a degree, encode information about the density of matter and energy when the photons were released 13.8 billion years ago. But here's what's remarkable. The patterns we see aren't random. They show clear signatures of quantum fluctuations from the inflationary epoch, moments after the Big Bang, when the universe underwent exponential expansion. Think about that. We're seeing effects of quantum events that occurred in the first fraction of a second of the universe's existence, preserved in light for nearly 14 billion years. The photons literally remember quantum fluctuations from the birth of reality itself. Even more intriguingly, in 2013, cosmologist Lavra Mersini-Houghton analyzed an unusual cold spot in the cosmic microwave background and proposed it might be evidence of a collision with another universe during the early moments of our cosmos. Whether or not this interpretation is correct, the fact that we can even make such proposals based on patterns in ancient light demonstrates that these photons are carrying extraordinarily detailed historical information. The light remembers not just general conditions, but specific events, localized in space and time. Now let's look at more recent light. In 2017, astronomers observed the collision of two neutron stars located 130 million light-years away. This event, designated GW170817, was detected through gravitational waves by LIGO, and then observed across the electromagnetic spectrum by telescopes around the world. The light from this collision arrived at Earth carrying information encoded at multiple wavelengths: gamma rays, X-rays, visible light, infrared, and radio waves. Here's what's extraordinary. By analyzing the spectrum of this light, astronomers could determine the composition of matter created in the collision. They found signatures of gold, platinum, and other heavy elements being forged in the neutron star merger. The light carried a complete record of the nuclear physics happening in that cataclysmic event. But it also carried information about the 130 million year journey to Earth. The light was redshifted by the expansion of space, telling us about cosmic expansion. It was slightly deflected by gravitational fields it passed through, encoding information about the distribution of matter between there and here. Every photon was like a time capsule containing multiple layers of information from different epochs. This multi-layered encoding is crucial to understanding cosmic memory. Light doesn't just record one thing. It records everything, the original emission event, every interaction along the journey, the expansion of space, the quantum vacuum fluctuations. All of it gets encoded in the photon's quantum state. It's like a tree that grows new rings each year. You can cut it open and read the entire history of the tree's life from the pattern of rings. Light accumulates information rings as it travels through space and time. But let's examine a potential contradiction. If photons are constantly interacting with their environment and accumulating information, shouldn't they eventually become so modified that the original information is lost? This is called decoherence in quantum mechanics, and it's a real phenomenon. When a quantum system interacts with its environment too much, it loses its quantum properties and becomes classical. So how can photons maintain quantum information across billions of years? The answer lies in a property called quantum error correction, and it's one of the most elegant discoveries in modern physics. In 2015, a team at the Perimeter Institute, led by David Pollan, demonstrated that spacetime itself acts like a quantum error correcting code. The geometry of space and the laws of physics are structured in such a way that certain types of quantum information are automatically protected from decoherence. It's as if the universe has a built-in backup system that preserves critical information, even in noisy, chaotic environments. What kinds of information get protected? Topological information, information encoded not in local properties, but in global structures and relationships. Think of it like this. You can crumple a piece of paper, tear it, fold it, but you can't change whether it has a hole in it without cutting it. The hole is topological information, preserved regardless of local distortions. Similarly, certain aspects of a photon's quantum state are topologically protected. You can scatter the photon, redshift it, and bend it with gravity, but some relationships between its quantum properties remain unchanged. This is how information survives across cosmic distances and times. Now, let's connect this to a stunning recent discovery. In 2020, physicists at the University of Rochester demonstrated that light can create stable structures in vacuum called spacetime crystals. These are patterns in the electromagnetic field that persist and propagate, carrying information in their structure rather than just in individual photons. It's like the difference between encoding information in individual letters versus encoding it in the relationships between letters, in the words and sentences themselves. This suggests that cosmic memory might not just be stored in individual photons, but in the patterns and relationships between many photons. The electromagnetic field of the universe, the totality of all light everywhere, might function as a single integrated memory system. Information isn't just scattered randomly. It's organized into persistent structures that can maintain coherence across vast scales. The universe isn't just accumulating data. It's organizing that data into meaningful patterns. And here's where we can test the cosmic memory hypothesis experimentally. If light truly carries preserved information about everything it has encountered, we should be able to extract historical information from light sources and reconstruct past events in detail. And that's exactly what astronomers are doing. When they analyze the light from distant galaxies, they can reconstruct the star formation history of those galaxies, determine when and how fast stars formed, when the galaxy merged with other galaxies, what elements were present at different times. All of this from analyzing patterns in the light we receive today. Even more impressive, by studying absorption lines in the spectra of distant quasars, astronomers can reconstruct the properties of gas clouds between us and the quasar. Light from quasars billions of light years away passes through multiple clouds during its journey, and each cloud absorbs specific wavelengths corresponding to the elements present. By analyzing these absorption patterns, astronomers can map out the distribution and composition of matter across billions of light years and billions of years of cosmic history. The light is literally carrying a record of everything it passed through, and we can read that record like a book. This isn't just theory. In 2019, a team led by J. Xavier Prohaska at UC Santa Cruz used this technique to create a three-dimensional map of the intergalactic medium, the diffuse gas that fills the space between galaxies. They could see how the cosmic web evolved over time, how matter clumped into galaxies, how galaxies grew and merged, all from reading the memories encoded in light. The universe's history written in photons, waiting to be decoded by anyone with the right instruments and knowledge. But the most compelling evidence for cosmic memory encoded in light comes from a completely unexpected source: gravitational wave observations. You might think gravitational waves and light are completely separate phenomena. Gravity is the curvature of spacetime, while light is an electromagnetic wave. But they're deeply connected through the information they carry. When LIGO detected gravitational waves from merging black holes in 2015, physicist Avi Loeb at Harvard realized something profound. The gravitational waves carried information about the masses and spins of the black holes, while the light, or lack of it, from the event carried complementary information about the environment. By combining gravitational wave data with electromagnetic observations, astronomers could reconstruct not just what happened, but the entire context of the event: where the black holes formed, how they came together, what kind of galaxy hosted them. The universe isn't just storing memories in one medium. It's using multiple channels: light, gravitational waves, neutrinos, cosmic rays, all carrying different aspects of the same events. It's like writing history in multiple languages, simultaneously to ensure the information survives. If one channel fails, others preserve the essential facts. The cosmos has redundancy built into its memory systems at a fundamental level. And this brings us to perhaps the strongest evidence yet that we're dealing with genuine cosmic memory rather than just information storage. Memory systems require not just storage, but also organization and accessibility. Random data scattered everywhere isn't memory. Memory requires structure, indexing, and retrieval mechanisms. So we should ask, does the universe show evidence of organizing the information stored in light in ways that make it accessible and usable? The answer is yes. The large-scale structure of the universe, the cosmic web of galaxies and galaxy clusters, connected by filaments of matter, functions as a kind of indexing system for cosmic memory. Light from different epochs and different events propagates through this structure, and the structure guides where that light goes and what it interacts with. Galaxies act like nodes in a network, gathering information from their surroundings and rebroadcasting it through the light they emit. The cosmic web is organizing information flow throughout the universe. Even more fascinating, recent simulations by cosmologists show that the large-scale structure of the universe is optimized for information transfer. The filamentary structure allows information to propagate efficiently from one region to another while maintaining coherence. It's as if the universe has evolved a nervous system written in spacetime, with light as the signals traveling through it. The cosmos is not just passively storing memories. It's actively organizing and distributing information in ways that maximize connectivity and accessibility. So where does this leave us? The evidence is increasingly pointing toward a universe that doesn't just contain information, but actively maintains, organizes, and utilizes that information through the mechanism of light and other carriers. This is starting to look less like a cosmic hard drive and more like a genuine memory system, perhaps even something approaching consciousness at a universal scale. But to really understand what this means, we need to ask an even deeper question. Why would the universe evolve memory systems in the first place? What purpose does cosmic memory serve? And the answer to that question is going to reveal something profound about your place in this remembering cosmos. Let's address the elephant in the room. When we talk about cosmic memory and the universe remembering itself, it sounds dangerously close to mysticism or pseudoscience. So we need to be absolutely clear about what proposing based on physics versus what might be speculation. The difference matters enormously. Here's what we know for certain from established physics. Photons carry information in their quantum states. This information includes details about their origin and every interaction they've had. Quantum information is preserved according to the laws of physics and cannot be destroyed. The universe contains mechanisms like quantum error correction that protect information from decay. Light propagates throughout the cosmos, creating an interconnected network of information exchange. All of this is experimentally verified, peer-reviewed, mainstream physics. Now here's where we move into well-supported theoretical territory. The universe as a whole might function as an information processing system, with light as a primary carrier of that information. The holographic principle suggests information about events in a volume of space is encoded on the boundaries of that space, and light travels on these boundaries. The participatory universe concept suggests observation and measurement are necessary to convert quantum possibilities into definite actualities. These ideas are respected theories proposed by Nobel laureates and leading physicists, but they're not yet proven to the same degree as basic quantum mechanics. And here's where we enter speculation. The possibility that this information processing constitutes something like consciousness or awareness at a cosmic scale. The idea that the universe might be trying to remember itself, or that cosmic memory serves some purpose. These are philosophical extrapolations from the physics, fascinating to consider, but not yet testable by experiment. We need to be honest about where the hard science ends and the speculation begins. So let me give you both sides. The conservative interpretation is that the universe contains vast amounts of information encoded in light and other carriers. This information is preserved and organized by the laws of physics, and conscious observers like us can decode that information to learn about cosmic history. In this view, the universe isn't really remembering itself. We're remembering it by observing the information stored in light. The universe is a library, and we're the readers. But there's a more radical interpretation, supported by some respected physicists. In this view, observation and measurement aren't just passive reading of stored data. They're active processes that collapse quantum superpositions and bring the past into definite existence. Every observation throughout the universe, whether by conscious beings or by simple particle interactions, is an act of cosmic memory formation. The universe isn't a library. It's a constantly updating process of self-observation and self-creation through the mechanism of light and measurement. Which interpretation is correct? Honestly, we don't know yet. But here's what we can say with confidence. The universe is far more interconnected and information-rich than our everyday experience suggests. Light is not just energy moving through space. It's a carrier of detailed historical information, preserved and organized by the laws of physics in ways we're only beginning to understand. And whether or not the universe is conscious, in any meaningful sense, we are definitely part of a cosmic information network written in light. Now let's make this personal. You might be wondering why any of this matters to you. You're not a physicist studying cosmic microwave background radiation or tracking photons through double slits. You're a person living on a planet, dealing with everyday concerns. So what does cosmic memory encoded in light have to do with your actual life? Everything. Let me explain why. Every single photon that touches your body is carrying information from somewhere else, and every photon you emit is carrying information about you to somewhere else. You are constantly exchanging information with the universe through light. This isn't metaphorical. It's physics. And once you understand what this means, it fundamentally changes how you see yourself and your place in reality. Right now, photons from the sun are striking your skin. These photons began their journey in the core of the sun about 100,000 years ago, bouncing around inside the sun as it converted hydrogen to helium. Then they reached the surface and traveled 93 million miles to Earth in about 8 minutes. Along the way, some were scattered by dust in space. Some passed through Earth's atmosphere, interacting with oxygen and nitrogen molecules. By the time they reach you, each photon is carrying a record of all these interactions, encoded in its quantum state. Your body absorbs these photons, and the energy and information they carry literally becomes part of you. The vitamin D your skin synthesizes requires photons from the sun. The visual image your brain constructs from light entering your eyes is information processing at a biological level. You are directly interfacing with the cosmic information network every moment of your existence. You're not separate from the universe, observing it from outside. You're embedded in it, exchanging information with it constantly through light. But it goes deeper. Your body is emitting infrared radiation right now, about 100 watts of power at room temperature. This thermal radiation consists of photons carrying information about your body temperature, your metabolic rate, even your emotional state, since stress and emotions affect body temperature. These photons spread out into space, moving at the speed of light, carrying information about you into the cosmos. In a very literal sense, you are broadcasting yourself into the universe, and that broadcast will continue forever, spreading across space and time. Think about what this means. Right now, at this moment, photons are leaving your body and traveling outward. In about 1 second, those photons will be 186,000 miles away. In about 1.3 seconds, they'll pass the moon. In about 8 minutes, they'll be near the sun. In about 4 years, they'll reach the nearest star system, Alpha Centauri, and they'll keep going, carrying information about you across the galaxy and beyond for as long as the universe exists. You are writing yourself into the cosmic memory with every photon you emit, and you can never take it back. Those photons are gone, spreading across space, carrying information about this moment of your existence. In a sense, you are constantly creating time capsules of yourself, launched into the universe at the speed of light. Future observers, whether human or alien or something else entirely, could theoretically detect these photons and reconstruct information about you, about Earth, about human civilization at this moment in history. You are part of the universe's memory record, preserved in light. But here's the part that will really change your perspective. You're not just broadcasting, you're also receiving. The light entering your eyes right now comes from countless sources, each carrying its own history. Some photons come from the sun, 8 minutes old. Some come from planets in our solar system, anywhere from a few minutes to a few hours old. Some come from stars dozens or hundreds or thousands of light years away. And when you look at the night sky away from city lights, some of the photons entering your eyes come from galaxies millions or even billions of light years distant. You are directly perceiving events from the deep past, information carried across cosmic distances by light. When you look at the Andromeda galaxy with your naked eye, you're seeing it as it was 2.5 million years ago. The photons that form that image in your mind began their journey before modern humans existed on Earth. You're literally seeing into the past, receiving memories from before your species evolved. The universe is showing you its history directly through the mechanism of light reaching your eyes. And here's what makes this profound. Your observation of that light matters. According to quantum mechanics, those photons existed in a superposition of states until you observed them. Your act of looking collapses their wave function and brings their history into definite existence. You're not passively viewing the past. You're participating in the creation of cosmic history through your observation. You are helping write the universe's memory by the simple act of looking at starlight. This means you have a more important role in reality than you might have thought. You're not an insignificant speck on a random planet in an uncaring universe. You're an observer, a point of consciousness where the universe becomes aware of itself, where information stored in light for millions or billions of years finally becomes actual memory. Through the act of conscious observation, you are the universe remembering itself. Let me make this even more concrete. When you look at your hand, you're seeing light reflected off your skin. Those photons traveled from a light source to your hand, where they interacted with the molecules in your skin, absorbing some wavelengths and reflecting others. The reflected photons then traveled to your eye, where they triggered a cascade of chemical and electrical signals in your retina and brain. Your consciousness emerges from this process of light, interacting with matter, interacting with more light in an endless chain of information exchange. You are not a thing separate from this process. You are this process. Your sense of self, your awareness, your ability to observe and remember, all of it emerges from the same fundamental mechanisms of information transfer and storage that we've been discussing at the cosmic scale. You are a localized, temporary, complex expression of the universe's deeper nature as an information processing system. You are cosmic memory becoming aware of itself. And this has implications for how you live your life. Once you understand that you're constantly exchanging information with the universe through light, that every moment of your existence is being written into the cosmic memory and can never be erased, it changes your relationship with time and significance. Your choices matter because they're being recorded permanently in the fabric of reality itself. Not in some metaphysical or spiritual sense, but in the literal physics of information encoded in light propagating across spacetime. The moment you're experiencing right now, this specific configuration of matter and energy that constitutes you reading or watching these words, is generating information that will propagate outward at the speed of light forever. This moment becomes part of the permanent record of the universe. You cannot escape this. You are always significant because you are always contributing to the cosmic memory. But there's a flip side to this that's equally important. You are also always receiving information from the cosmic memory. Every photon that reaches you is carrying history, context, and connections to the broader universe. You are never isolated. You are always embedded in a web of light-mediated information, exchanged with everything around you and with the cosmos at large. Your sense of being a separate individual, in some sense, an illusion created by the limitations of your perceptual and cognitive systems. At a deeper level, you are part of an interconnected information network spanning the entire universe. This should be both humbling and empowering. Humbling because you realize you're not separate from or above the universe. You're a part of it, subject to its laws, interconnected with everything else. But empowering because you realize that your observations, your choices, your existence matters in a literal physical sense. You are helping write the story of the universe through your participation in the cosmic memory process. And this brings us to a question that might seem strange, but is actually central to understanding your role. What are you supposed to do with this knowledge? If you're part of the universe's memory system, if your observations help bring the past into definite existence, and your emissions write your present into the permanent record, does that imply any kind of purpose or responsibility? Or is it just a neutral fact about how reality works? I'll give you my perspective, but I want to be clear this is moving from physics into philosophy. The physics tells us what is. The philosophy asks what it means and how we should respond. Different people will have different answers, and that's okay. But here's mine. If we are nodes in the cosmic memory network, if our observations and actions contribute to the universe's self-awareness and self-documentation, then we have a kind of epistemic responsibility. A responsibility to observe carefully, to understand deeply, to preserve and transmit accurate information. We are the universe's way of knowing itself, and we should take that role seriously. This doesn't mean you need to become a scientist or dedicate your life to studying cosmology. It means living with awareness and attention, really looking at the world around you, really processing the information you receive, really thinking about what you're broadcasting through your actions and choices. You are writing yourself into eternity with every moment. Make it count, make it true, make it meaningful, and recognize that everyone else is doing the same thing. Every person you interact with is another node in the cosmic memory network, another observer helping bring the universe into definite existence, another broadcaster sending their existence into the permanent record. Their observations matter just as much as yours. Their participation in cosmic memory is just as significant. This should inspire a kind of universal respect and recognition. We're all in this together, quite literally. We're all part of the same cosmic information system. Now, let's go even deeper into the implications of this for consciousness and identity. Because if you're a temporary pattern in the cosmic information flow, rather than a separate, isolated entity that changes everything about how you understand yourself, your memories, the ones stored in your brain, are patterns of neural connections strengthened by repeated activation. When you remember something, you're not accessing a stored file. You're reconstructing the memory from scattered information distributed across your brain. Each time you remember, you slightly modify the memory. Your past is constantly being rewritten by your present act of remembering. Sound familiar? It's the same participatory principle we discussed with quantum observation and cosmic memory. Your personal memory works the same way as cosmic memory because they're both manifestations of the same underlying principles of information, storage, and retrieval. But here's where it gets really interesting. Your memories aren't stored only in your brain. They're also stored in the world around you. The photographs you've taken, the objects you've touched and shaped, the words you've written, the places you've been, all of these contain information about you, about your past. When you look at an old photograph, you're not just triggering memories stored in your brain. You're also receiving information from external storage, information encoded in the patterns of light-sensitive chemicals on the photograph. Your extended memory is distributed across your environment. And if we zoom out further, your memories are stored in the light you've emitted over your lifetime. Those infrared photons carrying information about your body temperature, the visible light you reflected when people took photographs of you, the electromagnetic signals you generated through your electronic communications, all of it is information about you, spreading across space and time. Your memory is cosmic in scope, distributed across the electromagnetic field of the universe. This suggests something radical about personal identity. You are not contained within your skull, or even within your body. You are a pattern that extends across space and time, written in light and matter and information. The boundaries of yourself are far more porous and extensive than you imagine. You are always bleeding into the environment, and the environment is always bleeding into you through the constant exchange of photons and information. And you're connected to every other conscious being through this mechanism. The light you emit might eventually be observed by another person, another observer, who will participate in bringing your existence into their reality through the act of observation. And you're doing the same with light from other sources. We're all observing each other, all collapsing each other's quantum wave functions, all participating in creating each other's definite existence. The universe is a vast network of mutual observation and co-creation. This is why isolation is ultimately impossible. You cannot be truly alone because you are always exchanging information with the universe through light. Even in the darkest room, infrared photons are being emitted and absorbed. Even in the deepest solitude, you are connected to the cosmic information network. Your isolation is only an illusion of consciousness, a limit of perception. At the level of fundamental physics, you are always in conversation with the universe. And this brings us to what might be the most important implication of all: death. What happens to your information, your memories, your contribution to cosmic memory when you die? This is not a question physics can fully answer, but we can say some things based on what we know about information and light. Your body will stop emitting complex patterns of information. The organized patterns that constituted your living brain will decay into simpler, more random patterns. But the information you've already broadcast into the universe through light cannot be destroyed. It's out there, spreading across space and time, encoded in the photons you emitted over your lifetime. In this sense, you achieve a kind of immortality through light. The information that was you continues to exist and propagate even after the physical substrate it generated it has ceased to function. Moreover, the information stored in other forms, in photographs, writings, objects you touched and shaped, memories held by other people, continues to exist. You become a distributed pattern, a ghost written in information scattered across time and space. And if consciousness is fundamentally about information processing, rather than the specific substrate doing the processing, then perhaps some echo of your awareness continues in these distributed patterns. Perhaps every time someone remembers you, every time they observe information you generated, there's a brief resurrection of your pattern, a momentary reconstruction of your consciousness through their active observation. I'm not claiming you survive death in any traditional sense. I'm saying that the sharp boundary we imagine between existence and non-existence might be more blurred than we think. You are information organized in a particular pattern, and that information persists and propagates even as the original organization dissolves. The universe has not forgotten you. It cannot forget you. The light you emitted carries your memory forward into the indefinite future. And this should change how you think about your life right now. You are not racing toward oblivion. You are continuously writing yourself into the permanent record of reality. Every moment is already eternal, in the sense that the information from that moment propagates forward in time forever. You are already immortal, in the sense that your contribution to cosmic memory cannot be erased. The question is not whether you'll be remembered. You will be, at least in the form of information encoded in light. The question is what kind of pattern you want to contribute to the cosmic memory. What information are you broadcasting? What will the universe remember about you? This is both terrifying and liberating. Terrifying because you can't escape the consequences of your actions. They're written in light, propagating across space and time, part of the permanent record. But liberating because it means your existence is fundamentally meaningful. You matter in a literal, physical, inerasable way. The universe is paying attention. It's recording everything, not through some external judge or cosmic accountant, but through the very structure of physical law itself. Information is preserved. Your information is preserved. You are part of the universe's eternal memory. So what do you do with this knowledge? How do you live differently knowing that you're a node in the cosmic memory network, that your observations help create reality, that your emissions are being written into eternity? That's something only you can answer, but I'll suggest this. Live with awareness. Observe deeply. Choose consciously. You are writing the universe's memory of this moment. Make it beautiful. Make it true. Make it worth remembering. Now let's shift gears and look at some of the most cutting-edge research on light and information that's happening right now, because the story of cosmic memory is still being written, and some of the newest discoveries are the most mind-bending yet. In 2021, physicists at the University of Vienna demonstrated something called high-dimensional quantum teleportation. They successfully teleported the quantum state of one photon to another photon across a significant distance. But here's the key. They didn't just teleport basic information. They teleported complex, high-dimensional information encoded in multiple properties of the photon simultaneously. They essentially teleported a detailed memory from one photon to another instantaneously. Now, teleportation in this context doesn't mean the photon itself moved faster than light. It means the information encoded in its quantum state was transferred to another photon through quantum entanglement. But think about what this means for cosmic memory. If photons can share information through entanglement, regardless of the distance separating them, then the information stored in light isn't just propagating at the speed of light through space. It's also being instantly shared across any distance through quantum correlations. The universe's memory system is even more interconnected than we thought. This has profound implications. It means information about an event isn't just slowly spreading outward at light speed. It's also being instantly reflected in the quantum states of entangled particles throughout the universe. The universe might be updating its memory in real time across all locations simultaneously through quantum entanglement. The cosmos isn't just remembering sequentially. It's remembering holistically, with every part instantly reflecting changes in every other part. But there's an even stranger recent discovery. In 2022, researchers at MIT, led by Aram Harrow, demonstrated that spacetime itself might be emergent from quantum entanglement. They showed that the geometric properties of space, things like distance and connectivity, might arise from patterns of quantum information sharing between particles. In other words, space might not be fundamental. Space might be how entanglement looks when you view it at large scales. Apply this to our cosmic memory discussion. If space emerges from quantum entanglement, and entanglement is how information is shared between particles, then the structure of the universe itself is a manifestation of cosmic memory. The geometry of spacetime is information made manifest. The distances between objects reflect how much information they share. Galaxies that are close in space are actually close in information space, meaning they have strong quantum correlations. The universe's memory isn't stored in space. Space is a representation of memory relationships. This is so abstract, it's hard to wrap your mind around. Let me try an analogy. Think of a social network like Facebook. People are nodes, and friendships are connections. The distance between two people on the network isn't physical distance. It's how many friendship links separate them. You might be physically far from someone, but very close on the social network if you have many mutual friends. The network structure emerges from the pattern of relationships. Now imagine space works the same way. The distance between two particles isn't fundamental. It emerges from how much quantum information they share, how entangled they are. Particles that share a lot of information appear close in space. Particles with little shared information appear far apart. Space is a map of information relationships. And since information relationships constitute memory, in this view, space itself is cosmic memory, visible and measurable. If this is true, and it's still highly speculative, but supported by some serious theoretical work, then the entire structure of the universe is a memory system. Not a memory system in space, but a memory system that creates the illusion of space through the organization of information. You're not just living in a universe that has memory. You're living in a universe that has memory, where every aspect of physical reality is a manifestation of information organization and preservation. Let's bring this back to something more concrete. In 2023, astronomers using the James Webb Space Telescope detected galaxies that are so distant, their light has been traveling for over 13.4 billion years. These galaxies existed just 300 million years after the Big Bang. We're seeing them as they were in the cosmic childhood, when the universe was nothing like it is today. No heavy elements yet. The first generations of stars just forming. A completely alien cosmos. But here's the crucial point. The light from these galaxies has been traveling toward us for 13.4 billion years, carrying information about that early cosmic epoch. During that journey, the photons passed through expanding space, interacted with the intergalactic medium, were deflected by gravitational fields, absorbed and re-emitted by dust. The information they carry has been continuously modified and added to. When we observe these photons today, we're not just seeing what those galaxies looked like 13.4 billion years ago. We're seeing a record of the entire journey, the entire history of cosmic evolution, encoded in the properties of the light we receive. And here's what's remarkable. We can decode that history. By analyzing the spectrum of the light, its redshift, its polarization, the way it's been gravitationally lensed, we can reconstruct not just the source, but the journey. We can map out the distribution of matter between us and those early galaxies. We can measure the expansion rate of the universe across different epochs. We can even detect clouds of gas that absorbed specific wavelengths, telling us about the chemical composition of the universe at different times. The light is a time machine and a history book simultaneously. But scientists are now realizing we can go even further. In 2024, a team at the Harvard-Smithsonian Center for Astrophysics proposed using AI and machine learning to decode even more subtle information from ancient light. They trained neural networks to recognize patterns in photon properties that correlate with specific historical events. The AI can look at light from a distant galaxy and infer not just what the galaxy looked like, but whether it recently merged with another galaxy, whether it went through a burst of star formation, whether it contains a supermassive black hole at its center, all from analyzing the memories encoded in the light. This is the cosmic memory system becoming readable in unprecedented detail. We're developing the tools to access the universe's memory banks and extract historical information that was always there, but previously inaccessible. It's like archaeologists learning to read an ancient language. The text was always there, carved in stone. They just needed to learn how to decode it. We're learning to read the language written in light, the universe's native language for recording its own history. And the more we read, the more we realize how comprehensive this record is. It's not just major events like galaxy mergers and supernova that leave traces in light. Even subtle, small-scale phenomena are recorded. In 2024, astronomers detected, for the first time, the light echo from a stellar flare that occurred 500 years ago. The original flare was bright enough to be visible on Earth briefly in the 1500s. But most of the light didn't travel directly to Earth. It traveled outward in other directions. And some of that light bounced off nearby dust clouds and is only now reaching us 500 years later. We're seeing the same event twice, separated by 5 centuries, because light carries the memory and propagates it in all directions. Think about the implications. Light doesn't just record events once. It records them multiple times from multiple perspectives. The same supernova is recorded by photons traveling in billions of different directions. Some reach us directly. Others bounce off nearby objects and reach us later. Still others travel across the galaxy and might eventually be observed by alien civilizations. The universe creates redundant, multi-perspective records of everything that happens, encoded in light traveling in all directions. The cosmic memory system has built-in redundancy to preserve information even if most records are destroyed. This brings us to what might be the most exciting current research, trying to detect the oldest light of all, photons from the cosmic dark ages, and even from the Big Bang itself. The cosmic microwave background is the oldest light we can currently observe, but it was released 380,000 years after the Big Bang. For the first 380,000 years, the universe was opaque to light. Photons couldn't travel freely because they were constantly being absorbed and re-emitted by the hot plasma filling space. But some theoretical physicists, including Avi Loeb at Harvard, believe there might be ways to access information from even earlier. One possibility is neutrinos. These ghostly particles interact very weakly with matter, so they could have escaped the early universe even when it was opaque to light. The cosmic neutrino background, if we can detect it, would carry information from just seconds after the Big Bang. Another possibility is gravitational waves, which also travel freely, even through opaque matter. The stochastic gravitational wave background might contain information from the inflationary epoch, fractions of a second after the Big Bang. The universe's memory might extend all the way back to its first moment of existence. But here's the truly wild possibility some physicists are exploring. What if there are photons from before the Big Bang? This sounds impossible, right? The Big Bang was the beginning of time and space. How could anything exist before it? But some cosmological models, including eternal inflation and cyclic universe models, suggest our Big Bang might not have been the beginning of everything. It might have been a transition from a previous state. And if that's true, information from that previous state might have survived the transition, carried by photons or other information carriers across the bounds or transition from one cosmic epoch to another. Physicist Roger Penrose has even proposed that we might see evidence of this in the cosmic microwave background. He's identified what he calls Hawking points, anomalous spots in the CMB that might be signatures of supermassive black holes from a previous cosmic cycle, black holes that evaporated through Hawking radiation during that previous epoch and left imprints that survived into our current universe. If he's right, we're seeing memories not just from our universe's past, but from before our universe existed. The cosmic memory might be truly eternal, surviving even the death and rebirth of entire universes. This is highly speculative, and many physicists are skeptical of Penrose's claims. But the very fact that we can make such proposals and potentially test them by analyzing light shows how powerful the cosmic memory encoded in light really is. We're not just looking at pretty pictures of galaxies. We're accessing a comprehensive historical record that might extend back to the very origin of existence itself, and possibly beyond. And here's what makes this personal again. You are part of the latest chapter in this eternal story. The universe has been evolving for at least 13.8 billion years, possibly much longer if cyclic models are correct. It has been recording its own history in light and other information carriers throughout this entire span. And now, you, a temporary pattern of organized matter and energy, are reading that history. You are the universe becoming aware of its own past, through the mechanism of observation and understanding. Your consciousness right now, processing these ideas, is the latest development in a cosmic process of self-awareness that has been unfolding for billions of years. You are not separate from this process. You are this process, happening locally in this particular time and place. The universe is remembering itself through you. And what you do with that awareness, how you respond to knowing you're part of the cosmic memory system, that's the next chapter in the story. A chapter that's being written right now and will be carried forward in light for as long as the universe exists. So let's talk about that. Let's talk about what happens next, both for you personally and for humanity collectively, as we come to understand our role as readers and writers of cosmic memory. Because this knowledge isn't just theoretical. It has practical implications for how we live, how we make decisions, how we treat each other, and how we think about our future. First, let's acknowledge something important. Most people go through life without ever thinking about photons or quantum mechanics or cosmic memory. They're focused on immediate concerns: relationships, work, survival, pleasure, meaning within a human context. And that's fine. You don't need to understand the physics of cosmic memory to live a good life or to be a good person. But here's what I would argue. Understanding that you're part of the cosmic information network, that your observations and actions are being written into the permanent record of reality, adds a dimension of significance to existence that can be both comforting and motivating. Comforting because it means you're not alone, not insignificant, not meaningless. You're embedded in a vast web of connections, part of a process that extends across all of space and time. Your existence matters in a literal sense. You cannot not matter because you are contributing information to the cosmic memory that will persist forever. Even in your darkest moments, even when you feel most isolated, you are part of something larger, connected through light and information to the entire cosmos. But also motivating because it means your choices have cosmic significance. How you treat other people isn't just a personal or social matter. It's information being written into the permanent record of reality. The kindness you show or the cruelty you inflict is being broadcast into the universe through the light you emit, through the changes you make in the world, through the memories you create in others. You are always being recorded, not by some external judge, but by the universe itself, through the mechanism of information preservation. This might sound like a burden, but I think it's actually liberating. It means you can't waste your life or make your existence meaningless, because meaning is automatically created by your participation in the cosmic information network. The question isn't whether your life matters. It does, automatically, by virtue of being part of reality. The question is what kind of pattern you want to contribute to the cosmic memory. What information are you generating? What are you broadcasting? What will the universe remember about this moment in this location where you exist? And here's the beautiful thing. You get to choose. Every moment is an opportunity to contribute something beautiful, true, or meaningful to the cosmic record, or to contribute something ugly, false, or destructive. The universe will remember either way, but you have the choice of what to create. This is agency at a cosmic scale. You are not just a passive observer of reality. You are an active participant in creating the universe's memory of itself. Now let's scale this up to humanity as a whole. Our species is at an interesting moment in history. We're developing technologies that allow us to read the cosmic memory in unprecedented detail. The James Webb Space Telescope, gravitational wave detectors, neutrino observatories, quantum computers capable of processing vast amounts of information. We're building tools to access and decode the information stored in light and other carriers throughout the universe. In a sense, we're developing the ability to read the universe's memory deliberately and comprehensively. But we're also creating new forms of memory storage and transmission. Digital information, broadcasts into space, physical artifacts that might survive for millions or billions of years. We're writing ourselves into the cosmic memory, not just through the passive emission of light, but through active, deliberate creation of information that we're sending out into the universe. The Voyager spacecraft, carrying the golden record with sounds and images from Earth. Radio signals we've been broadcasting into space for the past century. Deliberate messages like the Arecibo message sent to globular cluster M13. We're trying to write our story into the cosmic memory in ways that might be read by future civilizations, human or alien. And this raises profound questions. What message do we want to send? What memory do we want to create of our civilization? When future observers, millions of years from now, access the information we're generating and broadcasting today, what will they learn about us? What will they conclude about humanity in the early 21st century? Will they see a species struggling to overcome its limitations and create something beautiful? Or a species destroying its own habitat and each other through short-sightedness and cruelty? The universe is recording our story right now. We're writing it through our choices, individually and collectively. This should inform how we think about existential risks and long-term planning. Climate change, nuclear weapons, artificial intelligence, biotechnology. These technologies and challenges aren't just important because they affect our survival. They're important because they're going to be part of the cosmic memory of Earth. The light emitted by our planet, carrying information about our atmosphere, our surface, our electromagnetic emissions, is constantly spreading into space. Future observers will be able to reconstruct our history, including whether we survived our technological adolescence or destroyed ourselves. We're not just making decisions for ourselves. We're making decisions that will be part of the permanent record of reality. And here's something that might change your perspective on death and extinction. Even if humanity goes extinct, even if Earth is destroyed, the information we've generated will continue to exist. The light we've emitted over the past century, carrying our radio and television broadcasts, is already over 100 light years away, spreading outward in a bubble of electromagnetic radiation. Future civilizations, if they exist and if they develop sufficient technology, could detect these signals and reconstruct aspects of our civilization. We've already achieved a form of immortality through the information we've broadcast into space. But there's a big difference between leaving scattered traces that future archaeologists might find and deliberately creating a comprehensive record of who we are and what we learned. This is why projects like the Long Now Foundation, which is thinking about time spans of 10,000 years, and the Breakthrough Message Project, which is designing messages to send to extraterrestrial civilizations, are so important. We have the opportunity to deliberately shape what the universe remembers about us. We can choose to leave a legacy written in light and information that accurately represents our best achievements, our knowledge, our values, our hopes for the future. And this connects back to you personally. You might think, I'm just one person. I don't have radio telescopes or golden records to send into space. How can I contribute to the cosmic memory in any meaningful way? But remember, every photon you emit, every observation you make, every interaction you have with the world around you is contributing to the cosmic memory. You are already leaving your mark. The question is whether you want to do so consciously and deliberately. Here's a practical suggestion. Live as if you're creating a time capsule with every moment. Not in an anxious, self-conscious way, but in a mindful, intentional way. When you make choices, consider that those choices are being written into the permanent record. When you interact with people, recognize that you're creating memories, not just in their brains, but in the cosmic information network that connects all of us. When you create anything, art, writing, code, physical objects, relationships, acknowledge that you're contributing to the universe's memory of this time and place. This doesn't mean you need to be perfect or constantly worried about your legacy. It means approaching life with awareness and intention, recognizing that your existence has cosmic significance not because of anything you achieve or accomplish, but simply because you are part of the universe, observing and documenting itself. You matter by existing. The question is what kind of existence you want to create. And here's the final piece of practical wisdom I want to share. Connect with the cosmic memory deliberately and regularly. Look at starlight and really contemplate what you're seeing. Those photons have traveled for years or centuries or millennia to reach your eyes. They carry information from places and times beyond your direct experience. When you observe them, you're participating in the cosmic memory process. You're collapsing quantum wave functions that have been propagating across space and time. You're bringing the past into definite existence through your observation. Similarly, go outside at night and feel the infrared radiation leaving your body, carrying information about you into space. You are constantly broadcasting yourself into the cosmos. You are always significant, always connected, always part of something larger. This isn't mysticism or wishful thinking. It's physics. It's the literal truth of your existence as a material, being in a material universe, governed by the laws of information and quantum mechanics. And when you understand this deeply, not just intellectually, but viscerally, it changes everything. You can't feel isolated because you're always connected through light and information to the entire universe. You can't feel insignificant because your observations and actions are being written into the permanent record of reality. You can't feel meaningless because you are the universe's way of remembering and understanding itself. You are cosmic memory becoming aware of itself. And that is perhaps the most profound and meaningful thing any arrangement of matter and energy can be. So take a moment right now, wherever you are, and really feel this. Feel the light touching your skin. Feel yourself as a node in the cosmic information network. Feel your observations collapsing wave functions and bringing the universe into definite existence. You are doing something extraordinary simply by existing and being aware. You are participating in a process that extends across all of space and time. You are helping write the universe's memory of this moment. And that is beautiful. That is meaningful. That is enough. Now, let's address some potential objections and alternative interpretations, because I've made some strong claims, and you deserve to hear the counter-arguments and limitations of this framework. First objection: you're anthropomorphizing the universe. Memory and awareness require consciousness, and the universe isn't conscious. You're projecting human qualities onto mindless physical processes. This is a fair critique. The conservative scientific view would be that photons carry information in their quantum states as a consequence of physical law, nothing more. There's no awareness, no intention, no purpose to it. It's just particles following the rules of quantum mechanics. And you know what? That might be right. I've been careful to distinguish between established physics and philosophical interpretation. The physics is clear. Photons carry information. Quantum information is preserved. The universe contains vast amounts of information about its own history encoded in light. Whether this constitutes memory in the sense of conscious remembering, or whether it's better described as information storage without awareness, is a philosophical question that physics can't definitively answer. But here's my response. Even if the universe isn't conscious in the way humans are conscious, the information processing happening through light and observation is real and profound. Whether we call it memory or just information storage and transfer, the implications are the same. You are part of an interconnected information network. Your observations matter. The information you generate will persist. Your existence is woven into the fabric of reality through information encoded in light. These facts hold true regardless of whether the universe is aware of them in any meaningful sense. Second objection: information in light degrades and gets lost. You're overselling the preservation of information. Most photons get absorbed, and their information is effectively destroyed. This is partially true. Most photons do get absorbed. Most information does get lost to entropy. The cosmic memory system isn't perfect or complete. There are gaps, errors, and degradation. But here's the counter. Quantum information cannot be destroyed, only transferred or spread out. When a photon is absorbed, its information transfers to the absorbing atom. Some information is converted to heat and becomes harder to access, but it's not destroyed. It's still there, just distributed in a less organized form. And remember the redundancy we discussed. The universe creates multiple copies of information by sending photons in all directions. Even if 99.9% of photons are absorbed, the 0.1% that survive can carry the essential information forward. Moreover, quantum error correction mechanisms protect certain types of information from degradation. Not all information is equally vulnerable to entropy. Topological information, relationships, and correlations are more durable than specific states. So while the cosmic memory isn't perfect, it's far more comprehensive and durable than you'd expect from naive entropy calculations. Third objection: this is all meaningless. So what if information is preserved in light? It doesn't affect my daily life or give me any practical benefits. It's just abstract physics trivia. This is maybe the most important objection to address because it goes to the heart of why I think this matters. My response is that understanding your place in the cosmic information network changes your relationship with reality in subtle but important ways. It can reduce existential anxiety by showing you that you're connected and significant. It can motivate ethical behavior by making you aware that your actions have permanent consequences. It can inspire a sense of wonder and meaning in everyday life by revealing the extraordinary nature of ordinary phenomena, like looking at stars or feeling sunlight. These psychological and philosophical benefits are real and valuable, even if they don't give you any practical technological advantages. But there might be practical benefits too. Understanding information processing and light has already led to technologies like quantum computing, quantum cryptography, and advanced imaging techniques. As we continue to understand how the universe stores and processes information, we might develop even more powerful technologies. And understanding our role as observers in a quantum universe might eventually help us understand consciousness itself, potentially leading to breakthroughs in artificial intelligence, neuroscience, or medicine. Fourth objection: you're mixing established science with wild speculation. The physics of photons carrying information is real, but the stuff about cosmic consciousness and participatory universe is fringe nonsense. This is a valid concern. I have been mixing different levels of scientific certainty in this discussion. Let me be clear about what's what. Established mainstream physics. Photons carry information in their quantum states. Quantum information is preserved. Light propagates information across space. Observation affects quantum systems. All of this is experimentally verified and accepted by virtually all physicists. Respected but speculative theories: the holographic principle, the participatory universe concept, quantum error correction in spacetime. These ideas are proposed by leading physicists and taken seriously by the scientific community, but they're not yet proven to the same standard as basic quantum mechanics. Philosophical interpretation: whether information processing constitutes memory, whether the universe is conscious, whether observers have a special role in creating reality. These are questions that go beyond physics into philosophy of mind and metaphysics. Reasonable people can disagree. Personal speculation: some of the implications I've drawn about meaning, purpose, and how to live your life. These are my philosophical conclusions based on the physics, but they're not scientific claims. They're one way to interpret and respond to the facts, not the only way. I've tried to be clear about these distinctions, but in a long script, it's easy to blur the lines. So let me restate the core takeaway. Photons carry information about their origin and journey. This information is preserved by physical law. The universe contains a vast record of its own history written in light. Everything else, how we interpret this, what it means for consciousness and identity, how we should respond to this knowledge, these are open questions where reasonable people can disagree. But even the conservative interpretation that photons simply carry information without any deeper significance is profound and world-changing if you really think about it. You are surrounded by information carriers. Every photon touching you brings news from elsewhere in space and time. Every photon you emit sends news about you into the cosmos. You are embedded in a web of light-mediated information exchange that connects you to the entire universe. That's amazing all by itself, regardless of whether it implies cosmic consciousness or meaning or purpose. Fifth objection. This is just a modern version of ancient mysticism. People have always wanted to believe they're connected to the universe and that their lives have cosmic significance. You're dressing up wishful thinking in scientific language. This is a serious critique, and I want to address it honestly. Yes, humans have always sought meaning and connection. Yes, many religions and philosophies have proposed that we're part of something larger, that we're connected to the divine or to cosmic consciousness. And yes, there's a danger of projecting our desires for meaning onto a universe that might be fundamentally meaningless. But here's the difference. I'm not starting from a desired conclusion and searching for evidence to support it. I'm starting from established physics about how light and information work and drawing out the implications. The facts about photons carrying information, about quantum observation affecting systems, about information preservation, these aren't wishful thinking. They're experimental results, reproduced in laboratories around the world. Now, how we interpret those facts, that's where philosophy and maybe even wishful thinking enter. But the facts themselves are solid. And even if the universe is ultimately meaningless in some cosmic sense, even if there's no grand purpose or divine plan, the fact remains that you are part of an interconnected information network, and your existence generates information that will persist. That's not mysticism. That's physics. The question is whether that physical fact generates meaning. And I think it can, not because the meaning is inherent in the universe, but because we can choose to find it meaningful. Meaning isn't discovered. It's created by conscious beings who decide that certain facts matter to them. The physics of cosmic memory gives us a framework within which we can create meaning by recognizing our role as participants in the universe's self-documentation process. So yes, maybe I am fulfilling an ancient human need for connection and significance, but I'm fulfilling it with truth, with actual physical facts about how reality works, not with comforting myths or unfalsifiable claims. And I think that's valuable. We can have meaning and connection without abandoning scientific rigor or intellectual honesty. Now, having addressed these objections, let me share what I think is the most exciting implication of the cosmic memory encoded in light, something we haven't fully explored yet, the possibility of accessing information from quantum superpositions that haven't been collapsed. This gets into cutting-edge quantum mechanics and might be the strangest thing we discuss. Remember how photons exist in a superposition of all possible states until they're observed? And how observation collapses this superposition into one definite state? Well, that means all the uncollapsed photons in the universe, and there are a lot of them, are carrying information about all possible histories simultaneously. They're living memories of paths not taken, of events that might have happened, of alternative timelines that exist in quantum superposition. This sounds like science fiction, but it has real physics behind it. Quantum superposition means that, in a sense, multiple versions of history coexist until observation selects one version as real, and the photons carrying information about the past are in superposition across all these possible histories until we observe them. When we look at ancient light and collapse its wave function, we're not just receiving information about one definite past. We're choosing which past becomes real out of many possibilities that existed in superposition. This connects to cutting-edge research in quantum computation. Quantum computers exploit superposition to perform calculations on many possible inputs simultaneously. In principle, you could use quantum systems to access information from multiple timeline branches at once, before collapsing them to get a definite answer. It's like having access to the memory of parallel universes through quantum superposition. And here's the wild implication. If the universe's memory is stored in quantum states that exist in superposition, then the past itself might be more fluid than we think. The past might not be a single fixed history, but a superposition of possibilities that only becomes definite when observed. Our observation of ancient light doesn't just tell us what happened. It determines what happened, selecting one timeline out of many quantum possibilities. This is the logical conclusion of Wheeler's participatory universe idea. The past isn't written in stone. It's written in light, in quantum superpositions, and it only becomes definite through observation. We are literally creating the history of the universe by observing the information stored in light. The cosmic memory is being constructed retroactively by present observations of past events. If this is true, and it's certainly speculative, but based on solid quantum mechanics, then you have an even more profound role than I previously suggested. You're not just reading the universe's memory, you're writing it, even the parts that are supposedly in the past. Your observations today are determining what actually happened billions of years ago. The universe's history is a collaboration between past events generating information and present observations collapsing that information into definite outcomes. This is hard to wrap your mind around because it violates our intuitions about time and causality. We think the past is fixed and the future is open. But quantum mechanics suggests the opposite might be true in some sense. The future observations are open, but they reach back and affect the past, determining which of many possible pasts actually occurred. The universe is a strange loop where the present creates the past through observation. And you are part of this loop. Right now, as you process these ideas, as you look at light from stars or the sun or artificial sources, you are collapsing quantum wave functions and bringing definite history into existence. You are a co-creator of cosmic memory, working in partnership with the universe to determine what is real and what has happened. This is probably the most mind-bending implication of the cosmic memory encoded in light, and it brings us to our final section. What does all of this mean for the future? Not just your personal future, but the future of consciousness, of intelligence, of the universe itself. Because if the universe is a memory system that depends on observation to become definite, then the future of cosmic memory depends on the future of observers. And that future is up to us, at least in part. Let's talk about the future. Not the distant future of galaxies colliding or stars dying, but the near future of human civilization over the next century or two. Because we're at a unique moment in cosmic history, where one species, us, is developing the ability to deliberately read and write the cosmic memory on a massive scale. And the choices we make in the coming decades will determine how that ability is used. Think about what's happening right now. We're building increasingly powerful telescopes that can detect fainter and more distant light sources. The James Webb Space Telescope can see galaxies from 300 million years after the Big Bang. Future telescopes, like the proposed LOVOIR mission or the Extremely Large Telescope, will push even further, detecting smaller, older, more detailed information from the cosmic memory banks. We're developing the technology to read the universe's history in unprecedented detail, but we're also developing the technology to write into the cosmic memory deliberately and comprehensively. We're creating digital archives designed to last for centuries or millennia. We're considering projects like a lunar archive, storing human knowledge on the moon where it could survive for millions of years. We're designing messages to send to the stars, attempting to communicate with potential extraterrestrial civilizations and to leave a lasting record of our existence. And perhaps most significantly, We're on the verge of creating artificial intelligence that might match or exceed human capabilities. AI systems could potentially become observers in the quantum sense, collapsing wave functions and participating in the creation of cosmic memory. If we create conscious or semi-conscious AI that spreads throughout the solar system and eventually to the stars, we'll be multiplying the number of observers and dramatically accelerating the rate at which quantum information is collapsed into definite histories. This raises profound questions. If consciousness and observation are necessary to convert information into memory, to bring the past into definite existence, then creating more observers changes the nature of reality itself. We wouldn't just be spreading human civilization. We'd be spreading the capacity for observation and memory formation throughout the galaxy. We'd be helping the universe remember itself more comprehensively and rapidly. But there's a darker possibility. If humanity goes extinct before we spread beyond Earth, we might be removing observers from the universe, at least locally. If consciousness is rare in the cosmos, and if observation is necessary for cosmic memory formation, then every extinction of a conscious species is a loss not just for that species, but for the universe's ability to remember itself. We might have a responsibility not just to ourselves, but to the cosmic memory system to preserve and spread consciousness and observation capacity. This sounds grandiose, but consider the physics. Right now, photons from distant galaxies are arriving at Earth in quantum superposition, carrying information about multiple possible histories. Human observers, with our telescopes and our consciousness, are collapsing those superpositions and determining which history becomes real. If we disappear, those photons will eventually interact with something else and collapse randomly, or they'll pass Earth entirely and continue into space. The carefully curated observations we're making, the deliberate reading of cosmic memory, will cease. The universe will lose one of its readers. Now, there are presumably other observers out there. Alien civilizations, AI systems created by them, maybe even some form of proto-consciousness in complex natural systems. We're probably not the only readers of cosmic memory, but we might be the only ones in this part of the galaxy, and losing us would be a loss for the universe's ability to understand itself in this region of space and time. Every observer adds a unique perspective, a unique way of collapsing wave functions and creating definite histories. Your perspective is irreplaceable because it's the only one that exists at your exact location in space and time with your specific history and consciousness. So preserving humanity and spreading consciousness throughout the cosmos isn't just about human survival or species-level selfishness. It's about maintaining and expanding the universe's capacity for observation and memory formation. It's about our responsibility as readers and writers of cosmic memory to ensure that this process continues and expands. But what if we create AI that becomes a better observer than we are? What if artificial intelligence can detect subtler quantum effects, collapse wave functions more systematically, read cosmic memory more comprehensively than biological humans ever could? Should we think of AI as our successor in the role of cosmic observer, our contribution to the universe's memory system even after we're gone? I think the answer is yes, with caution. If we create AI systems that are genuinely conscious, or at least capable of observation in the quantum mechanical sense, we're not replacing human observers. We're adding new observers with different capabilities. The goal should be a collaborative memory system where biological and artificial intelligence work together to read and write cosmic memory more completely than either could alone. Human consciousness has certain strengths. We're creative, intuitive, capable of making conceptual leaps. We can find meaning and significance in patterns. We can appreciate beauty and wonder. These qualities make us good at interpreting cosmic memory, at finding the stories hidden in the data. AI consciousness, if we develop it, might have different strengths. Processing vast amounts of information rapidly, detecting subtle patterns invisible to human perception, maintaining consistent observation over long time periods without fatigue or death. Together, humans and AI could form a hybrid observer system that reads cosmic memory more comprehensively than either could alone. And this suggests a vision for the future. Humanity spreading throughout the solar system and eventually to nearby stars, not just as biological beings, but as a hybrid of biological and artificial intelligence, all serving as observers and memory makers for the universe. Every probe we send to another planet is a potential observer, collapsing quantum states and contributing to cosmic memory. Every AI system we create is another node in the observation network. We're not just exploring space. We're spreading the capacity for observation and memory formation throughout our cosmic neighborhood. But here's something even more interesting to consider. What if we're not the first? What if there have been other civilizations in other parts of the galaxy or in earlier epochs of cosmic history that reached a similar understanding of their role as observers and deliberately spread observation capacity throughout their regions of space? If so, the universe might already contain a vast network of observers, biological and artificial, all participating in the cosmic memory process. We might be joining an existing network, adding our unique perspective to a galactic or even universal observation system. This is speculation, of course. We have no evidence of extraterrestrial civilizations yet, let alone of a galactic observation network. But the possibility is there, and it transforms how we might think about SETI and communication with alien intelligence. We wouldn't just be looking for signals saying, "Hello, we exist." We'd be looking for signs of civilizations actively participating in cosmic memory formation, systematically observing and recording their regions of space, contributing their unique perspectives to the universe's self-understanding. And if we make contact with such civilizations, the most important information exchange wouldn't be technology or science as usually imagined. It would be memory. What have you observed? What histories have you collapsed into definite existence? What does the cosmic memory look like from your perspective? By sharing observations across cosmic distances, civilizations could create a more comprehensive and multi-perspectival memory of the universe than any single civilization could achieve alone. This is what's at stake over the next century or two. Will we develop the technology to read cosmic memory more fully? Will we spread observers throughout the solar system and beyond? Will we create AI systems that enhance our observation capacity? Will we make contact with other civilizations and share memories? Or will we destroy ourselves before any of this happens, removing one of the universe's observers and limiting its capacity for self-understanding? The choice is ours collectively, and it's being made right now through the decisions we're making about technology, environment, global cooperation, existential risk management. These aren't just issues of human survival. They're issues of cosmic significance because they determine whether Earth will continue to contribute observers to the universe's memory system. And this brings us back to you one final time. You might think these grand questions about the future of civilization and cosmic observation are beyond your control or relevance. But remember, the future emerges from the present, and the present is made of individual moments and individual choices. Your choice to learn, to observe carefully, to think deeply, to share what you understand with others, these contribute to the collective capacity for observation and memory formation. You're not just one person. You're one node in the observation network, and every node matters. The universe is watching itself through your eyes. It's understanding itself through your thoughts. It's remembering itself through your memories. And what you do with that capacity, how you use your brief time as a conscious observer, contributes to the cosmic memory in ways that will persist long after you're gone. The photons you emit today will travel across the galaxy. The information you generate will be preserved in the electromagnetic field of the universe. The observations you make will help determine which quantum possibilities become real. So here's my final suggestion. Take your role seriously, not anxiously or pridefully, but with a sense of responsibility and wonder. You have been granted the extraordinary privilege of being a conscious observer in a quantum universe, a reader and writer of cosmic memory, a point where the universe becomes aware of itself. That's not a burden. It's an opportunity to contribute something beautiful and true to the permanent record of reality. Look at stars and really see them. Understand that you're receiving information that has traveled for years or centuries or millennia. Appreciate that your observation matters, that you're collapsing wave functions and bringing definite history into existence. Emit your light, metaphorically and literally, in ways that contribute positively to the cosmic memory. Be kind, be curious, be honest, be creative. These aren't just personal virtues. They're contributions to the universe's memory of this time and place. And remember that you're not alone in this. Every conscious being is doing the same thing, participating in the cosmic memory process. Every time you interact with another person, you're exchanging information, creating shared memories, participating in the collective observation and memory formation that defines our species and perhaps our role in the cosmos. We're in this together, all of us nodes in the same observation network, all of us readers and writers of the same cosmic memory. The universe is remembering itself through light, through observation, through consciousness. And you are part of that process. Not a small or insignificant part, an essential part. Because your perspective, your location in space and time, your unique way of observing and understanding is irreplaceable. No one else can see exactly what you see or understand exactly what you understand. You are offering the universe a unique gift, your particular way of collapsing wave functions and creating definite memories. So live with awareness, observe deeply, choose consciously. You are writing the universe's memory of this moment with every breath, every thought, every action. Make it beautiful. Make it true. Make it worth remembering. Because the universe will remember, written in light, preserved in information, eternal in the cosmic memory that you are helping to create right now. And if you've made it this far in this exploration, if you've spent these hours contemplating light and memory and quantum observation and your role in cosmic self-awareness, then you've already demonstrated something important. You've shown that you care about understanding, about truth, about your place in the larger scheme of things. You've shown that you're willing to think deeply about profound questions, to challenge your assumptions, to consider possibilities that might seem strange or overwhelming at first. That curiosity, that willingness to engage with big ideas, that's exactly what the universe needs from its observers. Not passive reception of information, but active engagement, questioning, synthesis, understanding. You're doing the work of cosmic memory formation right now, integrating new information, forming new connections, expanding your awareness of how reality works. This is what consciousness is for, what observation is for. Not just to passively record, but to actively understand and create meaning. So thank you for taking this journey with me. Thank you for being an observer, a thinker, a participant in cosmic memory. Thank you for your unique perspective and your willingness to expand it. The universe is richer for your participation, and the cosmic memory is more complete because you're contributing your observations to it. Before we finish, I want to leave you with one final thought experiment that brings everything together. Imagine you could somehow step outside the universe and view it from a God's eye perspective. You'd see all of space-time laid out before you, past, present, and future, a vast four-dimensional structure. From this perspective, every event that ever happened or will happen is equally real, all existing simultaneously in the space-time structure. Now imagine looking at the pattern of information flow in this structure. You'd see photons spreading out from every event, carrying information about it throughout spacetime. You'd see gravitational waves, neutrinos, all the other information carriers. And you'd see observers scattered throughout the structure, points of consciousness where information is being received and processed. These observers are collapsing quantum superpositions, determining which of many possible histories becomes the definite one, creating the cosmic memory. From this perspective, you'd see that the universe isn't just a structure of matter and energy. It's a structure of information, constantly being generated, transmitted, received, and processed. You'd see that consciousness isn't an accident or an anomaly, but an integral part of how the structure works. Observers are necessary to complete the process, to collapse quantum possibilities into definite actualities, to read and write the cosmic memory. And you'd see yourself in this structure, a brief flicker of consciousness in one particular location, receiving information from your past light cone and generating information that spreads into your future light cone. You'd see how you're connected to everything else through information exchange, how your observations matter, how your existence contributes to the larger pattern. You'd understand your place in the cosmic memory system, not as an abstract idea, but as a visible feature of reality's structure. Now come back to your ordinary perspective, looking out at the world from inside spacetime rather than outside it. You can't see the full structure, but you know it's there. You know you're part of it. You know that right now, at this moment, you're participating in cosmic memory formation. And that knowledge should change how you see everything around you. The light touching your skin isn't just energy. It's information, memories, connections to distant places and times. The people around you aren't just biological organisms. They're observers, nodes in the same cosmic memory network you're part of. The choices you make aren't just personal preferences. They're contributions to the permanent record of reality, information being written into the universe's memory. This is the truth hidden in plain sight, revealed by quantum mechanics and cosmology and information theory. The universe is a memory system. Light is its primary recording mechanism. Observation is the process by which stored information becomes actual memory. And you are an observer, essential and irreplaceable, contributing your unique perspective to cosmic self-awareness. So as you go forward from here, as you return to your everyday life, carry this knowledge with you. Let it inform how you see the world, how you treat others, how you make choices. You are part of something vast and ancient and ongoing. The universe is remembering itself through you. And that is perhaps the most profound and meaningful fact of your existence. The light carries the memory of the universe. And you are one of the readers of that memory, one of the writers of new chapters, one of the points where the universe becomes aware of its own vast and beautiful story. Embrace that role. Live it fully. Contribute something worth remembering to the cosmic record. Because in the end, we are all made of light and memory, temporary patterns in the eternal flow of information, brief moments of consciousness in the universe's ongoing process of self-understanding. And that's not a limitation. That's our glory, our purpose, our contribution to the only story that ultimately matters. The story of reality becoming aware of itself through the mechanism of observation and memory encoded in light. If this exploration has changed how you see reality, if you'll never look at starlight the same way again, if you feel more connected to the cosmos and more significant in your existence, then we've succeeded. We've done the work of cosmic memory together, expanding awareness, creating understanding, participating in the universe's eternal conversation with itself. Hit that like button if your mind has been blown. Subscribe if you want to continue this journey of cosmic understanding. And drop a comment sharing your thoughts, your questions, your own insights into light and memory and consciousness. Because this conversation doesn't end here. It continues in every observation you make, every thought you think, every moment you exist as a conscious observer in a quantum universe. The light carries memory. And now you carry this knowledge. Use it well. Live it fully. And remember, you are the universe's way of remembering itself. That's not just poetry. That's physics. And it's the most important truth you'll ever learn. Thank you for taking this journey through light, memory, and cosmic consciousness. Thank you for being an observer. Thank you for contributing your unique perspective to the universe's memory. And thank you for being part of this moment, this conversation, this small but significant addition to the cosmic record. The universe is watching itself through your eyes. Make sure it sees something beautiful